so today we're going to be focused on our key question of solutions. How do we make sustainable changes? So you're going to hear this word sustainability a lot, and it's a balance between people, planet, and profit. So people is social, planet is environment, and profit is economic. You don't have to know these three ones that are in betweens, but know that we're always going for something sustainable, that kind of target in the middle. So for social aspects or people, it's going to make life easier, more pleasant. It's going to make your life happier, better quality, better relationships. People like to do it if it's sustainable. If they don't like to do it, it's not sustainable. For planet, it's going to use resources effectively and efficiently. So it considers both direct and indirect impact. So direct means like we're actually getting something out of the ground, and what kind of damage does that do? Indirect is things like, have we paid attention to how much energy it takes for transportation, storage, all of those types of other impacts that we don't always think about. And then economic, does it make a profit? Is it affordable? Does it save people money? So an example of not sustainable was if it's inconvenient, it makes me unhappy, it costs me money, and it doesn't help the environment very much, it's definitively not sustainable. But if it's something I like to do, I enjoy, makes me happy, saves me money, and helps the environment, then it is sustainable. So when we're thinking about solutions, we think about those aspects of sustainability. Oftentimes when we talk about sustainability, our focus is on energy. And so hopefully as kind of a quick review for energy, you're thinking about renewable versus non-renewable resources, right? So renewable resources are ones that can be replaced over a short period of time. So there are things like trees, water, solar power, wind power, geothermal, and biofuels. We'll talk more about those alternative fuels here in a little bit. In general, renewable resources are clean, or they don't have carbon dioxide, or they may actually reduce carbon dioxide if it's something like biofuels or trees. The drawbacks for most renewable ones are we need what's called infrastructure changes. We'll talk here about that word infrastructure in a second. But we also have kind of a chicken and egg thing going on. We don't have a big supply of renewable resources, so there's not a lot of demand. So then do you generate the renewable resources to increase demand, or do you have people demand it so that we can increase the resources? Which has to come first? Non-renewable resources, on the other hand, are resources we currently use that take long periods of time to replenish. So it's things like fossil fuels like natural gas, coal, oil, but it's also things like minerals like uranium or metals. So for most of these, our infrastructure is in place, which means they're inexpensive and easy to use. It makes them more equitable and accessible for everyone. Drawbacks, though, are that fossil fuels produce a lot of carbon dioxide. We, of course, then have limited amounts available. As we use them up, they don't regenerate. And there's global politics and lots of money involved. We'll talk about that here in just a second. So when we talk about that word infrastructure, it's the know-how and equipment and logistics that it takes to use something. So like for example with our fossil fuels, we know how to use fossil fuels. We know how to get them out of the ground. We know how to make them into fuels. We have the equipment to do all that. So we've got the mining equipment. We've got the refinery equipment. We've got the transport equipment. And so the logistics, we have all the people in place that need to transport, get them out of the ground, refine them, so on. All of that makes it cheap, and so whenever you have infrastructure in place, it really makes it accessible. So then when we're thinking about energy and carbon dioxide and climate change, we have to think about how we use energy. So currently, as of 2021, 12% of our energy came from those renewable resources and 87% came from non-renewable resources, which is only a change of about 2% since the year of 2017. So in that, call it 5 years or so. And here we're going to be talking about these different kinds of energy today. But we also need to think about who's using that energy. So if we think about who's using those kinds of energy, notice how industrial is our biggest, transportation is our second biggest, and residential is our third biggest. This is important when we think about people part of sustainability, because a lot of the marketing you'll see is about people making individual choices, when really it's our industries that are using the most energy, which also brings that carbon dioxide into play, because are we looking at point source versus multi-source? Point sources come from one single location. So when we're talking about that carbon dioxide, and here in Nebraska, in Omaha in particular, we have one point source for our electricity, which is coming from our coal plant. And so that's a point source location. But multi-source carbon dioxides come from multiple locations. So specifically, we're thinking about transportation industry here. All the different cars and trucks that burn those fossil fuels and release that carbon dioxide. So when we think about solutions, we have to think about which one's easier to control or impact, point sources or multi-source. So in general, what you're going to see happen in the future is we move towards more of those point source locations. And so when we think about those global politics and money, one of the things we have to consider is that fossil fuels are still subsidized. So subsidies are tax credits. They help industries to get started, to keep from failing, to get on their feet, and stuff like that. Make that product more, or that industry more equitable, more affordable for the consumer. And so when we think about fossil fuel subsidies, we've been using fossil fuels since the Industrial Revolution. And worldwide, fossil fuel industry currently is subsidized by about $423 billion per year. So in the United States, that translates to about $20 billion per year. 16 billion is going to oil and gas. So your taxes are going to that oil industry, which reduces our federal revenue by approximately $11.5 billion. And production subsidies are actually growing. Subsidies are originally made so that you can get an industry going and then reduce those subsidies over time. So like our wind industry subsidies were very prominent in the late 90s, early 2000s, and they have since been removed. But on the other hand, our oil subsidies are still growing. So when we talk about that economy piece, and when we talk about that economy piece, that's one of the things we have to consider. So what do we do? Alternative fuels is one solution that we can look at when it comes to energy. And so we're going to look at those alternative fuels that are those renewable resources, and we're going to ask those big questions. Is it clean? Is it renewable? Is it efficient? And will it fit our current infrastructure? So anytime you see this symbol, that is a turbine, and that indicates old infrastructure. So that's kind of how fossil fuels work, is by turning that turbine. So wind goes to the electrical industry, and it is turning a turbine. It turns the turbine using that wind power. So it's clean, it's renewable, it's efficient, it's dependable. The earth is heated unevenly, so the wind is always going to blow. And it has possibility of providing 80% of U.S. electrical energy in North Dakota and South Dakota alone. The problem is our electrical grid is too old to be able to do that. The drawbacks is the cost of that land use, as well as the technology itself. And so the other one is technology, size, and transportation. Here we see a horizontal turbine, and here's one of those blades. Notice this is a semi-truck, a normal size semi-truck, with a little bit longer trailer on it, and this is sticking out still past that. I had to watch this tractor take a couple of shots at getting around this corner because they just didn't fit. And so we can't make these any bigger to increase electrical production, and we're kind of limited by that size. This video you can look at on Google Classroom, but what it shows is one of the common concerns is often listed for turbines as noise pollution. I took this video in 2014. I pulled over at a rest stop to take that, and so you'll hear wind noise, and you'll hear the traffic noise behind me. If you look up how much noise a turbine takes, a turbine will give off 43 decibels. Your home air conditioner outside your home puts off about 50 decibels. A really loud refrigerator would be 40 decibels. And so when you think about that, is it really all that noisy for this great big ginormous turbine? Nuclear power is the next one we're going to talk about. That's the fission or breaking of those big nuclei, like uranium. It currently provides 9% of U.S. energy, and it does turn a turbine, so it's old infrastructure. It's on demand, which means if everybody comes home and turns on their air conditioner, we can kind of crank up the reaction and get more energy. It does not produce carbon dioxide, and it's highly efficient. You can get lots of energy from a little bit of material. The problem is there's safety issues with the reaction itself, as well as the waste disposal that comes with after that is done, and it's not renewable. So between the safety hazards with the plant itself and the nuclear waste, this is our Fort Calhoun plant. It is currently on the process of being decommissioned because OPPD has determined it is too expensive. So that's something that our community has deemed is not sustainable. Also in Google Classroom, you'll see another video there I'm skipping over that shows what on demand looks like. It's a little clip from National Lampoon's Christmas Vacation. So solar energy is the next one. There's two types. There's passive, like when we stand in the sun to get warm, but active solar energy is used to heat or generate electricity. So this one is a solar array. So you see all these mirrors kind of pointed at the center tower. In that tower would be a tank of water, which would turn a turbine. That's old infrastructure. And we're generating electricity for the electrical industry. But this is also this is a photovoltaic cell. So this is, if you've ever been down to the baseball field for maybe College World Series or a concert, this is Creighton University's photovoltaic or solar array. And those are photovoltaic cells. That's actually new infrastructure. This also takes solar power and turns it directly into electricity. So this is clean, renewable, no carbon dioxide. The drawback is the equipment cost for something like this, and you also need a backup or storage for nighttime and cloudy days. We have efficiency in both categories here because it depends on how you look at efficiency. If you're looking at the amount of energy coming into the planet, are we collecting it all? No. So then you can argue that it's not efficient. But you can also look at it as efficient in terms of that's energy we haven't been using before. So yes, it is very efficient. So depending on how you look at efficiency, you could put it in both categories. The next one we're going to talk about is hydroelectric power. This is electric power that is due to falling water that turns a turbine. So this is old infrastructure. It's renewable, it's clean, it's efficient, does not produce carbon dioxide, but hydroelectric also has a lot of drawbacks. Hydroelectric dams are limited in where we can place them, and also they have limited lifetimes. So this one's the Hoover Dam, and this is Lake Mead behind it. So not only do you have to worry about land rights upstream, you have to worry about water rights downstream. The Colorado River no longer reaches the Gulf of Mexico because of the dams that are on the Colorado River, like the Hoover Dam. And so this does fit the electrical industry. Here's an example, though, of that Lake Mead. And so we can see it in 2000, 2021, and 2022, and we can see how that lake level is decreasing. So this is due to a lack of water in that area. So the Hoover Dam supplies electricity to 1.3 million people in Nevada, Arizona, California, and they're going through a drought right now. We're losing a lot of this water to the sandstone around, but also not getting recharged. So now not only are they under a fresh water crisis, they're also under an electrical energy crisis because they are losing that water. So geothermal is another one. There's two types of geothermal. This is both types work by using energy from the Earth's core. You can have a heat pump, like this image over here, or you can have steam. So if you have a heat pump, like this is what we have, this vertical field here is what we have at Westside. This is how our HVAC system works. It increases our efficiency because the ground stays at about 50 degrees. So in the wintertime, that's much warmer than our winter air. And in the summertime, it's also much cooler than the summer air. So you bring fluid through these pipes and then you put it into your building, and then you can use the heating or cooling capacity of the fluid in those pipes to then heat or cool your air so that your furnace or your air conditioner doesn't have to work as hard. It's clean, it's renewable, and it decreases the carbon dioxide production because we're not running that furnace as much, or we're not running an air conditioner at all. If you're looking at a large scale system, on the other hand, you're actually looking at some sort of vent where we can get to the magma of our planet. You run some hot water over that, you generate some steam, and you can actually make electricity using that turbine. So geothermal is really an old infrastructure. Drawbacks, though, on that large scale kind of hot spot electrical generation, you're limited by where you can do that. Like, we don't have any place to do that in Nebraska. But small scale, we're looking at the cost of this installation of this, as well as land space. Like, I'm a homeowner with a postage stamp for my backyard. I can't fit one of these in my property. Biofuels, this is one, I put a state of Nebraska over this because this is our home state's this is one of our primary income generators. This one hits the transportation industry. So up till now, we've really looked at the electrical industry, but this one actually hits our transportation industry. So this is old infrastructure, and what it does is it takes plants like corn and soybeans and turns that into ethanol, which is fuel for our cars. This increases it's got greater efficiency than fossil fuels when you look at the actual amount of energy we can get per gallon of ethanol versus fossil fuel gasoline. It lowers use of pesticides and lowers erosion, so it's got land conservation, and we can even recycle the byproducts of that back onto fields. Because the plants use carbon dioxide for photosynthesis, it reduces the carbon dioxide that we are putting into the air by reducing the amount of fossil fuels we burn. But also, when we do burn that ethanol, it puts the same carbon dioxide back into the air, so it's net zero carbon dioxide. The drawbacks, though, we have a public perception of efficiency, and a lot of times we use miles per gallon. And ethanol in general is more efficient because it decreases your cost per mile, but your parents might not think it's efficient because their miles per gallon goes down. So we need to think about miles per gallon versus cost per mile when we're thinking about efficiency. The other thing is land use when we're talking about energy. Who wants to use land for energy? We don't usually value that. We value things like shopping malls and hospitals, and we want to put more retail type things on our land, and so we cannot use that land for development or other usage. The other thing is we need to develop some different transport systems because ethanol is a little more corrosive. Our infrastructure needs a bit of tweaking. It still is old infrastructure, but we need some adaptations to it. The last one I'm going to just barely touch briefly on is hydrogen. We thought this one was going to be something that would hit the transportation industry, and the Toyota Mirari was one that was attempted, but this one really hasn't taken off in the transportation industry. In essence, what it does is uses hydrogen as a fuel cell or rechargeable battery, and it is no carbon dioxide if it's made with renewable fuels, but it really hasn't been embraced by the transportation industry. They really have abandoned hydrogen to go for electric cars instead. So you can dig into that if you want. All right, so that is, in short, your sustainability and your alternative fuels.